Good morning, everyone. So it's time to start. My name is Selinger. I'm a product manager for the Central Northern European area at Avanzare. And today is the last session of our last series of webinars. We will be focusing on the specialty additives for plastics that we develop. And of course, the aim of this webinar is on one side to introduce to those that know about us and the products that we develop and what we do at Avanzare, and for those that already know us and we're working with them, hopefully to expand their knowledge about our capabilities. And this webinar is aimed at everyone from a technical perspective or position to understand the capabilities of our product, and at the same time as well for people that are on other roles, for example, in sales, to get ideas about what they can offer to their clients, new possibilities, and also options for the development of new products, of course. So let's start with it. So a little bit about Avanzare. As you may know already, Avanzare is a company located in the north of Spain, in La Rioja, and we have been developing for more than 15 years specialty additives for different industries, such as plastics, rubbers, and resins. Avanzare first started as an R&D research center. We were helping all kinds of manufacturers to solve particular technical problems they were not able to solve with additives that were available in the market. And logically, over time, during these 15 years, we have developed such a large number of products and projects that also allowed us to adapt and standardize many of them and offer them to the rest of the market, of course. It is worth highlighting that a big part of the colleagues at Avanzare are also still involved in R&D roles, which I think highlights the character of the company, where we're not only just focused on producing on one particular product, but also in constantly working together with the clients in either developing new solutions or adapting existing solutions to their particular needs and requirements in terms of processes, materials, and so on. Within the R&D team, we have colleagues that are specialized in all kinds of topics: biology, biochemistry, chemistry, and so on. All of our products are customized, are manufactured and developed in Europe, Spain, but of course, we're all working with clients all around the world, and we also have colleagues in different regions of the world. In order to highlight also a little bit the factor that Avanzare has such an R&D focus character, I wanted to show this slide just to show all the kind of R&D projects that we're involved, because this is logically also a big part of Avanzare, not only the additives that we develop, but also the type of R&D projects that we're involved in at the European level, all kinds of projects related to graphene, to design of 3D printing technologies, UV stabilizers, and so on. Generally speaking, there is no limit on the topics we want to get involved with. When we talk about the products and the specialty additives that we develop for plastics, logically we can highlight 6 main types, starting with our colorless and unpermanent antistatic or ESD additives. This is the main market for Avanzare. We will go into it in the following slides, as well as graphene. By production capacity, we're one of the largest producers of graphene in Europe. We have a big range of different grades for different purposes, for different industries, and also different solutions adapted to the specific requirements of each client. Chemical tracers, these are customized additives that we developed for avoiding illegitimate claims or copies of industrial materials like rubber, plastics, and so on. Magnetic tracers and density amplifiers. These are metallic powders which allow for the detection of plastic pieces in different areas like production lines. And the same powder can also be used to amplify the density of different plastics. Furthermore, we also have worked with different types of biocides or antimicrobial additives for different purposes. And lastly, we can also highlight other additives that we have developed and sell, such as flame retardant additives, anti-block, anti-odor, and so on. When we talk about antistatic agents, we have to also take into account what technologies are out there right now in the market to add such characteristics to plastics. As we all know, by nature, plastic tends to be an insulative material, and logically, in particular applications, this is not the best, and it is required to add certain electric conductivity properties to this material. As we can see in the right graph, this is the status quo of additives right now in the market to add such properties to plastics. On the very left, we will have the most conventional materials that are used for such purposes, which can be conductive carbon black or graphene. They have the advantage that they can give very good conductivities to different materials, but logically they have a limitation in terms of the color. It will generally be black, and also in terms of the amount of the material that you have to add in order to reach such conductivity. Logically, when we talk about these systems, we also have to take into account that the kind of conductivity that we achieve is generally below 10 to the power of 6 or 10 to the power of 5 ohms, which is good, of course, for those applications that actually are requiring a conductive material. But when we're just looking for an antistatic or ESD performance within a material, it can be too much. And we have also to look into other options also because of specific norms we may have to work with. Here, logically, we want to highlight that the technology we work with. It's ionic conductors. These are colorable and permanent materials, which once integrated within a polymer or a matrix will allow for the electricity to flow in a controlled manner. When we speak about controlled manner, logically, we're talking about different resistivities, which generally range from the 10 to the power of 5 to 10 to the power of 9. For example, in the left, you will see, for example, according to different norms, that there are ranges where we have to stand within. For example, in footwear or flooring systems, for example, ideally, in order to have a ESD performance, we would be at the point that we start at 10 to the power of 7 below. And lastly, it is also worth highlighting that there are other additives in the market to add antistatic performance to different plastics, which may be, for example, migratory additives, which are also, for example, colorable, are also cost efficient, but do not have the characteristic of giving a permanent performance over time, which is, of course, on the other side, again, not desirable for different applications. But of course, there are other applications where this might be just sufficient. So when we analyze what kind of additive or what the client wants to achieve in a particular material, we have to raise some questions in order to identify the best solution for them. For example, if they want to achieve a permanent or a not permanent antistatic behavior or performance, if they want to achieve a black material or a colorless material or a colorable material, what are the conditions of use? Some antistatic additives, especially the migratory, for example, are dependent on humidity to give such performance, and in some cases, this is not sufficient. And most importantly of all is the range of conductivity. It's very important from the very beginning, define exactly what the client wants to achieve in terms of what resistivity they want to achieve and which type as well, because we can measure resistivity on the surface, we can measure resistivity in a volumetric way, and depending on the application material, well, these requirements will change, and of course also the type of additive to use. As I said before, here is a little overview in this table of the differences of these additives that we highlighted, what is possible with each of them, either dependent on humidity or not, and what you can achieve in terms of resistivity. In the right slide, we will also see the evolution of resistivity of these different additives. For example, when we take into account migratory additives, generally the resistivity that you can achieve is not that low, but for example, for some applications like anti-dust, it may be enough. And of course, over time, this resistivity, the effect is disappearing, which generally is starting after even 2 or 1 month. On the other side, our ionic conductors or graphene improve the resistivity, the conductivity of the material over time, especially when we're looking for a permanent effect. And as I said before, it is a matter of what you want to achieve in each project or application. Some other characteristic of our ionic conductors is that generally a low dosage is required. For example, this is very preferable compared to with black systems. They're cost effective, are non-migratory, and most importantly, we have different solutions for different requirements. Either if you're needing a solution in a solid format, in a liquid format, in a pellet format, depending on your product and process and material. We also have food grade antistatic additives for different applications, and of course we adapt them for any kind of process if you're either in compounding, extrusion, and so on. I would like to start with an overview of one type of antistatic additives that we have for plastic, which is the range of Avanzare additives. They are characterized or also called IDPs, inherent dissipative polymers. And basically, these are additives in pellet form that allow for the creation of an electrically dissipative network inside of polymer. This can be different to other additives we will see in the following slides, as they may be while the other ones have the characteristic of dispersing completely within a material. This is different with the kind of Avanzare. Most importantly, because of the polarity of some polymers. Not always it is possible to change the polarity of such polymers in the way that we can reach such resistivities, but simply because of the nature of the polymer itself, and therefore we have to work with what is called IDPs. And the IDPs characterize themselves for being a polymer with such conductivities that in a way is compatible enough and also not compatible enough with the material, in the sense that it will create a network inside of such polymer without breaking such their bonds or their channels, and without dispersing completely. Otherwise, we would lose this effect. But it is by default needed to create such elastic, let's say, elastic network inside of this polymer in order to allow for the electricity to flow from one point to another. Otherwise, because of the nature of the polymer, as I said before, it would be very difficult to modify the material in order to reach such conductivities. Once again, it is very important when we select a product from our Avanzare range to identify very well what is the type of polymer we're working with, and even if you can tell us more information about the characteristics of the polymer itself, like the MFI and so on, it is good to know, because we have a lot of experience and data on the workability of our additives under different conditions and material, and this will make it easy for us to help you at the end. It's also important to explain and to define the process where you will be using them. Most importantly, the processing temperature will also change the suitability of one additive or another, and of course other requirements as for example if you require food contact. Here we can highlight 4 main products that we work with within the Avanzare range. all of them suited for different characteristics. For example, Avantis 232 is particularly suitable for materials like HIPS, PS, PP, PE, and so on, particularly when we are working at processing temperatures over 230 degrees. And generally speaking, and within its limits, of course, it is the higher the temperature, we will observe better performances. On the other side, for example, alternatively, we can, for example, work with Avantis 765, particularly if you're processing at temperatures below 230 degrees. And here also equally, it works with other types of polymers such as TPE, SEBS, and so on. Avantis 378 is another very interesting solution. Logically, it's also suitable for different types of material. It's more of a versatile solution, which logically can also allow you to reach the same performance with a lower dosage, but logically it will also depend on your cost calculations. And lastly, for example, in case you have food contact requirements, for example, we can recommend Avantis 450, which is equally suitable for different types of polymers, including polyolefins. And yeah, it can comply with different FDA or different European food contact regulations. As I said before, the format of these additives is in pellet format. The usage rate will depend on the resistivity that you want to achieve. You can reach resistivities from 10 to the power of 10 ohms, or as low as, in some cases, 10 to the power of 7 ohms. And it will vary between a dosage, generally speaking, of 10 to 22, 25%, depending on what you want to achieve, of course. Furthermore, on other antistatic ESD additives that we work with in plastics, we have, as I said, different grades for different requirements. For example, we can highlight the solutions that we have for TPU, here also in pellet format, either if you're requiring food contact or not. For example, other products like Avanstatic 1050 for PVC or TPU in liquid format, which with a very low dosage, you will achieve the resistivity that you're looking for example, 10 to the power of 9. For polyamide 6, for example, we also have different solutions, both in liquid and master batch format, also if you're requiring with food contact, and as well in for PET, for example, we can highlight Avanstatic P890. As you may notice, and as I explained before, while with the Avantis range, you want to create a network that will allow for the conductivity, and this entails in some cases a dosage up to 20%. In some with some of the other additives we work with in other plastics, where you can achieve such resistivities which are with a much lower dosage. But logically here, the technology and how it and the effect that it has into the polarity of the polymer changes. So please, whenever you need our support to select an additive, it is always good to share as much information as you can about the project itself, so that we can help you the best. And don't limit yourself to the additives that I have displayed here, because logically over time we have developed others. But yes, it's always good that you tell us what you want to achieve, so that we can help you select from the general range of products that we have, or from some other new developments that we are doing, and so on. One of the products I also wanted to highlight here is the Avanstatic P890. This is particularly suitable, for example, for PET, and we can also do, aside of the powder format that we usually produce this material, we can also prepare customized master batches, for example, also in a PET carrier, and it's basically as many of our ionic conductors is based on functionalized silica with an excess of cations and ions, which once integrated into a matrix will allow for the electricity to flow. It does not alter the original material mechanical properties. You can achieve the desired resistivity with a relatively low dosage between 3 and 6%. And for example, in the graph that you see in the right, you will see under different dosages where you have what you can achieve, either for example, a 3% dosage 10 to the power of 9 ohms, and if you increase to 6%, for example, with this particular PET, you can achieve 10 to the power of ohm. Logically, it will also depend on your specific material. So you will, of course, whenever you may try one of our additives, you will, of course, may be able to reach even better conductivity depending on your material. It will depend, of course. Some examples and applications and examples of applications and cases, of course, this will vary a lot throughout industries. We can highlight, for example, different kind of film bags for electronics, which by default need an ESD, need ESD characteristics in order to avoid, well, to compromise the electronics itself, whether it will be disposed, and this can also apply, for example, to sheets, no, for the thermoforming of different ESD trays for electronics. Also, for example, different ICT tanks, for example, may also require antistatic performance in terms of safety. Cables, for example, different kind of wheels, different kind of flooring tiles for clean rooms or different scenarios, different kind of extruded profiles, plastic sheets, different kind of pipes, for example, that we can see on the bottom right, even in the case that it is about a pipe for food processing. Of course, we also have antistatic additives for food contact or different kind of mixing tanks, as we can see on the bottom right. These are just some ideas and some of the cases we work on, but logically it will depend on the applications and the industry you work on, and in some cases you may need antistatic performance, in some cases you may not, but it will depend, of course, on the particular application and project. Now we're going to talk a little bit about the graphene and its applications in plastics and the graphene grades that we produce. As I said at the beginning of the webinar, we produce a big range of different types of graphene grades, and this ranges from grades that are focused on for industrial purposes and some other that are focused for research purposes. For example, when we talk about graphene for industrial purposes, we're talking about graphene nanoplatelets. As we know, graphene is they call it wonder material. It was discovered in 2010, and it gave its inventors the Nobel Prize. And it is basically a 2D sheet structure of carbon atoms, which are arrayed in a honeycomb array in a 6C form. When we talk about graphene nanoplatelets, we're talking about of carbon sheets of more of 10 layers. While when we're talking about other graphene grades, we're talking generally of such graphene sheets of less than 10 layers, getting to the point of only 1 layer. Logically, in order to scale up the process and make it accessible to industrial markets, for example, sometimes it is sufficient to work with graphene nanoplatelets in order to achieve the desired effect. But in some cases, for example, especially in the new industries where they're really researching the properties of graphene in different applications, we can be talking about pristine graphene, highly reduced graphene oxide, partially reduced graphene oxide, and of course we also produce different kind of dispersion and master batches. Generally speaking, it is possible to characterize graphene depending on different characteristics like the content of oxygen, its thickness, its lateral size, the production method, the surface area, the defects and surface and chemistry, and logically the different characteristics of each grade will be better for one material or another material, for one purpose or another purpose. For example, when we're talking about thermal conductivity, the larger the lateral size, the better. But it will depend on what you want to achieve, of course. From an industrial point of view, the main applications or the most interesting characteristics that graphene can provide with different polymers are mostly focused on electrical conductivity and thermal conductivity, mechanical properties, or different type of barrier or fire retardant properties. This doesn't mean it is not being researched, especially at the R&D level, for other kinds of applications and characteristics, but this is mostly focused when we're talking about applications for plastic or industrial applications. When we talk about electrical conductivity with graphene, we can see in the right table a similar dynamic as we would see with conductive carbon black, where in order to reach a certain resistivity, you have to surpass a percolation threshold. This basically means that, as you can see in this image over here, until you do not load the material with sufficient material that creates a consistent network from one side to another, you will not have the desired resistivity. But once you do, of course, the resistivity will drastically drop to very low levels. Of course, as I said at the beginning, this can be desired or not in some applications, but particularly it's interesting when you want to achieve very low resistivities. And as with conductive carbon black, we have to keep in mind that this is a black material. We can also develop different kinds of master batches and have different standard grades of graphene-based master batches to basically facilitate its dispersion in different processes, particularly when we're working with graphene in powder format. It can be tricky if you're not experienced or don't have the right equipment for it in order to disperse it. And for this reason, for example, in order to make the life of some of our clients easier, we have developed specific master batches which allows them to integrate them into different processes and materials. A little bit more about some of the master batch graphene-based master batches that we have. It is worth highlighting that they can be suitable both for conductive and ESD performance. They are pH and halogen-free. It has a low impact in the key mechanical properties, and they're effective and stable under different humidity conditions. For example, one of these grades is Avanzare 505, which, for example, can allow you to reach resistivities around 5 ohms per square centimeter. The dosage will depend between, for example, 15 to 50%, which allowing you to reach resistivities as low of 10 to the power of 2. Another grade, for example, can be also Avanzare P700. This is more suitable, for example, for injection, and depending on what you want to achieve as well, it will change. We have also studied logically the effect of for example, of our master batches in different materials. For example, in this table, we can see the effect that it has on the different dosages in pp, and it is also worth highlighting, for example, that the processing temperature it will also have an effect on the dispersion and the conductivity that it will provide to a material. There are different applications such as electronic packaging, fittings, ATEX solutions, where you may want to use such materials. And of course, it is always important to highlight as well that graphene should not be only viewed as a replacement to conductive carbon black, but can also be used, for example, for other purposes within the same application. For example, if you want to partially replace conductive carbon black or other conductive materials in order to compensate the loss of mechanical properties, or if you want to look for a synergistic effect, for example, in order to reach lower resistivities and so on. When we talk about thermal conductivity with graphene, and personally speaking, this is one of my favorite applications for this material. We have selected different grades of graphene grades, which characterize for having a bigger lateral size, which will allow for a better thermal conductivity. We mostly work with Avanzare conductive 440. This is more suited for industrial grades, and the dosage that is required to reach increase the thermal conductivity of a polymer can vary between 3 and 16%. For example, while we still scale up the production of some other grades, for example, another interesting grade to look into, particularly for research purposes, can be Avanzare conductive 770, which logically also has a higher performance. As with the other graphene grades, they are also halogen and PAH free, and it has a low impact in the key mechanical properties. For example, in this slide on your right, you will see the effect that it has, the different grades that I just explained in polyamide 6 and the thermal conductivity, which is measured in meter Kelvin. For example, we can see that with the polyamide 6 that has a starting point of 0.28, for example, if we focus on the grade for 40, we can quickly double this conductivity with only 10%, which is already a great improvement. We have to take into account that there aren't that many other additives in the market to increase the thermal conductivity of different polymers in such way and at such relatively low dosages for the effect that it has in the end material. The performance is logically permanent as with the electric conductivity, and we also have master batch versions of this product. It can be loaded, for example, in different carriers such as EVA, different types of polyolefins, and we're talking about loadings of up to 50%, of course. Here's another some more data on the effect of Avanzare conductor 440, for example, in this case in TP. And it is important also to highlight, especially when you're speaking to a client that wants to achieve such effect in an end product, that it is very important to define from the very beginning the starting point of the polymer you're working with, where you want to get in terms of improvement, and most importantly, how you're going to measure it. Because as we can see in this, comparing these two slides, while we increase the dosage of the conductive, thermally conductive graphene, while the increase in volumetric or through the plane will be relatively incremental, I would say, for example, when we measure it into superficial in plane, it will be more exponential almost. So the higher the load, the higher it will be the difference between both measurements. So this is why it's very important to define from the beginning what the client wants to achieve, because it's not the same to increase the thermal conductivity from volumetric by 10 than increasing it in superficial by 10%, for example. As I explained, Avanzare 440 master batch 50, for example, is a master batch solution of this thermally conductive graphene, and it can be prepared in EVA, polyolefins, or many different polymers you may be required. For example, here are some of the characteristics of this material. But as I said before, if you have any particular requirements, it is best to tell us directly what you want to achieve rather than selecting, for example, from the information I'm giving here. Another interesting material that we have as an alternative to the range of graphene-based Avanzare conductive is Avanzare 300. This is a colorable alternative for thermal conductivity properties. It is based on a mixture of different metallic oxides, and it is important to highlight as well that it will not provide electric transmission. While we talk with graphene, we also have to logically consider that at some point, when we add a thermal conductor, we will also we will go through the percolation threshold, and we will also have some electrical conductivity characteristics. Of course, there are different ways just to have one property and not the other. But for example, if you're looking for a colorable alternative that also does not give any kind of electrical transmission, Avanzare 300 is also a very interesting material to look at. In terms of mechanical properties, logically, this will vary a lot in terms of the material, the application you're working with. It is worth highlighting that when we're working with graphene for mechanical properties, the dynamics in terms of dosaging are quite different. For example, if we want to increase the Young modulus or some other mechanical properties characteristics of polyamide 6, we will have the best improvements at very low dosages, generally below 1%, or even in some cases with just 0.1%, you will have a very interesting increase of different types of mechanical properties and in different polymers. The same goes, for example, with the tensile modules. In this graph, we can also observe how at extremely low dosages below 1%, you are already increasing the tensile modulus by 40%, which is quite incredible considering the improvement and considering the low dosage of the material we're adding. Other improvements in mechanical properties can be observed, for example, in impact properties, for example, in PP, also at very low dosages. In this case, for example, you can observe an increase of 270% in terms of impact energy in PP, and so on. Of course, if you want to research the effect of graphene that graphene can have in terms of mechanical properties in your material, as usual, it is best to tell us for what exactly, and so that we can recommend the best grade, even give dosage suggestions, processing suggestions, and so on. Because of the good thermal conductivity characteristics of graphene, it is logically a good material to help in terms of flame retardancy properties. For example, we have one grade that is Avanzare GR8, which works as a synergistic with conventional flame retardant packages. I would not generally recommend this as the standard flame retardant additive and the only flame retardant additive for an application, but rather as a booster of those packages that you may be already using. Particularly interesting, for example, when you need to comply with a particular norm and you're not able to achieve this with these conventional flame retardant packages based on polyphosphates and so on. For example, in this graph, you can see how a little tiny 2% of Avanzare GR8 in combination with the reference compound and other flame retardant additives can boost to a certain extent the flame retardancy properties of such materials, which in some cases will actually help you to reach or to comply those norms that are not easy to accomplish with the conventional materials out there. For example, we have also improved, and some of our clients have also observed that some of our graphene grades are very interesting when we want to increase the gas and liquid barrier or impermeability properties. For example, in this picture, you can see which is basically a latex ball, which goes inside of a football ball. And by adding a small dosage of graphene, for example, of Avanzare 40 at 5% or less, they were able to have very interesting improvements of such properties, especially in this particular case for gas or gas or air impermeability, but in some other applications, you may want also to improve the liquid barrier or impermeability properties. So moving on to another topic, it's our range of products of Avanzare detector. As I explained at the very beginning, this is an additive in powder form. It is based on stainless steel alloy, and it is basically designed to impart detectability by metallic, magnetic, or X-ray methods. This is a colorable alternative to a material you may be more familiar with, for example, ferrite, which can also help you in such cases, but it's not that suitable because it will turn your product black. And particularly in the applications where you want to give such properties to plastics, for example, it is important to be able to color the material. For example, this is particularly important in food production processes, where it is very important not a single piece of plastic of whatever is in the plant. This can include the conveyor belts. This can include the pens of the operators or any other plastic piece that they carry on them, or any other tool or utensil that is used in that production line. And logically, in some cases, over time, either by accidents or by degradation of these materials, you have the risk that a small, tiny piece falls into the line, which is very undesirable, as it may end up in the final product. And no one logically wants to, for example, find a piece of plastic in a food product, no? It is worth highlighting as well that it is odorless, it's non-migratory, it complies with different food contact regulations. It is quite competitive in price to other solutions as well. For example, steel fibers, which may also be used in such applications. And logically, these pieces can be detected throughout the production line with different kind of detection machines. For example, in the right picture, we see a magnetic arc or a magnetic detection machine, which will allow for the detection of such pieces. When developing a product like this for a client, it is also very important to determine the size of the piece they want to detect within their line. In some cases, just by law, larger pieces, for example, by 7 by 7 millimeters, are required to be detected just to avoid the risk of choking. But in other cases, logically, you want to be able to detect even smaller pieces, which may be, for example, coming from the degradation of a material, from, for example, a bucket that you may be using repeatedly to put a product into the line, and eventually it will may degrade to some extent, and a tiny little piece may fall. So depending on the size of the piece that your final client wants to achieve, the dosage of this additive will also vary. It may, in some cases, for larger pieces, 3% dosage of Avanzare may be sufficient. But if you want to go, for example, as low as 3 by 3 by 1.5 millimeter, a dosage of 14%, for example, may be required. So when speaking with a customer about this, especially when they're new on this, it is very important to define this. And logically, how the detection machine is calibrated, for example, and the metallic spheres that are used to calibrate such detection machine will also have an influence. And logically, when we're looking for very low, very small pieces, which in some cases, if we set the detection machine into extremely high sensitive, we may also fall in the risk of having false positives, even from a little extra oil that may fall in the line. Different applications for Avanzare detector in detectability. As I said before, everything that can be used in a food production line or a plant, and this can vary as tanks, buckets, different kind of ties, different kind of pipes, especially for example, pipes may be susceptible of internal degradation and the release of such of the pieces of the pipe itself over time, and so on. Even card holders, pens, everything, absolutely everything that may be used in that production line. Furthermore, also similar grades to Avanzare, also based on stainless steel, may be also used, for example, to amplify the density of a plastic. There are different reasons why you may want to achieve this in particular applications. They may be as simple as to avoid that the plastic floats, but in other cases, for example, it can be also be used, for example, in applications where you want to, let's say, improve the appearance of a product. And this can range, for example, of increasing the weight of a casino chip, just so that it looks more heavy and better, or different kinds of luxury packaging. It varies. It's the applications are the range of applications here are very big, and even we get surprised from time to time from what clients want to achieve with something like that because of their specific requirements. And of course, it is as well food grade compliant, valid with the European regulation 10 2011. It is colorable and we can also produce it in different carriers in master batch form for you. The next range of products we will talk about is the chemical tracers. And the first generation of chemical tracers that we developed were because of a client who had one particular issue. He was a producer. He is a producer of a material in large quantities. It is a product that is not marked, so it is not possible to identify if it is his product or not. Especially in the case, for example, in this case where he had, there were different companies supplying to the same client the same product unmarked. In some cases, this client had the issue that his final client would come to him and tell him, this piece broke, this piece is not working as expected or as claimed, and he was simply not able to make sure if that was his material or not, or if it was a copy or not. And from there, he wanted us to develop an additive that would allow him in such cases to identify if and confirm if that is his material or not. And this is when we developed the first generation of our chemical tracers, which are tailor-made additives based on organometallic compounds. They can be added to different kind of polymers at very low dosages, so for example, it's 300 ppm. And logically, depending on what you want to achieve, it can be designed in one way or another. For example, when we start a project like this with a client who wants us to develop an additive for him, we also start asking them what kind of equipment they have in their laboratory. Understanding the equipment that they have in their laboratory, particularly to identify or analyze different materials, will allow us to develop it in a way that in a first level, they could identify or at least make a first identification of the additive inside of the material. Logically, over time, we have developed different projects for this, and we can develop them in different ways, for example, in different levels of security. The highest level of security would be what we call reverse engineering proof, which would be basically focused on creating 3 different compounds at 3 different percentages. Therefore, even if they try to reverse engineer it in order to copy your material with the additive, it will be extremely unlikely that they will get the 3 right compounds in the 3 right percentages. Because logically, in later stages, together with this service, also we include around 2 analyses per year, which would allow our client to also have another another party confirming that this is not their material. Particularly important, for example, when they engage into some kind of legal action because of this claim of a material not working and similar. Furthermore, we can also design it in a way that it allows material producers, for example, not to do only an analysis about if the additive is inside or not, but also in a quantitative way. For example, in the TPU industry, where it is quite common to, in the end application, to, for example, mix different kind of TPUs in different dosages. This is quite interesting because if a final client, for example, the TPU producer, is making a claim that his material is not performing, and he may suspect that he may have mixed it with another material, and this may be the source of the material not performing, they would be able to verify to which extent it was mixed with another material because of the end content of the additive inside of it and inside of the end material. A little bit about biocides now. We have registered, of course, our biocides in Europe, and for example, they are also registered at the European level, for example, in Germany, and we work with different technologies. Today, we will be talking mostly about our two main products, which may be zinc oxide back or Avansilver back. Zinc oxide back is, as I said, is a powerful biocide agent, especially formulated to be introduced in plastic matrices. It is based on zinc oxide and zinc pyrithion, and depending on you want to achieve it, it's also very important to define with the client. Generally speaking, when we're talking about biocidal action, you may be looking for an antibacterial effect, you may be looking for an anti-fungi effect, an anti-algae effect, and logically the tests that you have to pass also are different. For example, you may be also looking for an antiviral effect. You may be also wanting to just to achieve, for example, an antifungal effect, which will derive in an anti-odor effect, for example, in shoe soles, where one wants to eliminate, for example, the fungal smell of soles that are generated by the growth of fungi. And as an alternative, when one is processing over 240 degrees, for example, or when they are looking for a food grade compliant biocide, we can also work with silver, for example, in this case, Avansilver back. Logically, we can also prepare all kind of dispersions, or, for example, of master batches, which may facilitate the integration of these biocides into a material or production. And for example, we also have an antimicrobial laboratory where, for example, we can provide the service of carrying out the most common test, for example, for such antibacterial tests is the ISO 22196, and we can carry out this in our laboratory. A little bit more about our best seller in terms of biocide products. As I said, is zinc oxide back, ZNO back. And the dosage, it will vary on what you want to achieve, of course. It may vary between 0.1% and 0.3%. More polarity and less crystallinity is better for the performance. And as I said before, it can also be prepared in a master batch format. For example, if we look into the different regulations, we have to look also into what we want to comply with, if it's a preservative, if for what kind of material, and so on. There will be different regulations, and of course, you can also refer to the webinar that Dr. Javier Perez gave a couple of weeks ago. It is published in our YouTube channel, where we talk extensively about the different topics related to biocide regulations in different regions, different concepts around this, and so on. Examples and of applications and cases for biocides. Well, it will vary a lot, and especially in the times we live right now, everyone even more wants to achieve such properties in different materials. Just a couple of examples, all kind of materials inside and related to windows, for example, just to avoid the mold or the algae that may grow out of humidity, different kind of, for example, soles, different kind of films, for example. This can include films that protection films, for example, that can be put on tables and surfaces, or other type of films that are used in packaging, food packaging, different kind of trays, especially used in food, different kind of fittings and pipes, different kind of shields, for example, especially quite popular in the last years, and so on. For example, there are always also alternatives. For example, not only it is good to integrate this into the final material, but also to develop it in different ways. And of course, once again, don't limit yourself to the products I've just explained here. We have different also variations. We are constantly also working into new versions to comply with newer regulations and the restrictions of the previous ones, and so on. Lastly, I also wanted to highlight the capabilities of Avanzare in terms of our antimicrobial laboratory. Here we can carry out different tests. The most common that that at least I work with clients in Europe is the ISO 22196, but of course we can also carry them out according to the Japanese standard, which is the one that was used to base the former one I just mentioned. There are different kind of tests that we can carry out. For example, the Kirby-Bauer qualitative test, quantitative methods for the determination of minimum inhibitory concentration of microbial growth, and so on. Lastly, and as an overview, and as also some to do a starting point of other topics, I also wanted to highlight other additives we have worked in the past, just to also transmit to everyone who's listening today that we are more than happy to listen to every technical challenge that one is working on, in case we can help them either with something that we already have or something we could develop. It fits logically the focus in terms of chemistry of the topics we work on. For example, we have developed different kind of additives for anti-fog properties, laser maker properties, oxygen scavengers, IR absorbers for PET, outdoor UV protectors, PC light scatterers, coupling agents, photocatalysts, anti-odor, anti-block, and so on. Tell us whenever you need something in particular. Of course, there are some topics we focus on, principally like providing electric conductivity, especially at the ESD level, different materials. But as you could see through this presentation, we're open to any challenge, and look at us not only as a developer and producer of R&D of specialty additives, but also as an R&D platform to support you in solving different kind of technical problems. Also, to give you an overview about the global network of Avanzare, as I said before, we're located in the north of Spain, and this is where our production plant is. We equally have warehouses and representatives and colleagues in different parts of the world, particularly in China, in Southeast Asia, in India. We also work with distributors in the rest of the regions, such as Russia, such as America, such as South America, Australia, and other parts of Asia. So whenever you have an inquiry, don't hesitate to contact our local representatives directly or through our website, and we will be logically happy to refer you to the most relevant person in our team for your particular project. Lastly, I also wanted to highlight the different kind of technical capabilities that we have. As I said at the beginning, we do not only have a production plant, but we have a large R&D and laboratory capabilities. And this can be used by our clients for all the stages of development of a new project, from the point of us, for example, adapting or producing a dispersion or a master batch according to a particular requirements, or also logically at the later stages when, for example, they may need support for testing this material. For example, we have also an antistatic laboratory where we can carry out all kind of antistatic and resistivity tests under the particular norms that are required to comply with, or the conditions in terms of humidity, temperature, and so on. And of course, we have a large number of other departments in terms of laboratory to analyze different aspects. For example, Ensatec is part also of the Avanzare group. It is an accredited certification lab for building materials, where we're on a daily basis, we're testing all kinds of different type of material buildings, from windows to different kind of everything that may be used in construction. And logically, this also gives us, for example, the capabilities to and the equipment to test other things not accredited. For example, if we're talking, for example, about fire tests in other kind of cable applications or something like that necessarily, but we have the equipment, and logically, when we're working with a client in developing or boosting the flame retardant properties of a particular project, we can also help them in testing it, so that it's just to make it easier for them, of course. So I would like to thank you for your time and for joining this joining this webinar. As I said, I hope this is a starting point, also an opportunity to brainstorm, to give you ideas from both from a technical and a sales perspective. You have here my data. Also, you have access to our website where you can contact us, but feel free to contact me anytime, either to say hi or to discuss any particular project you may have, of course. Thanks a lot. And now we will move on to we will look if we have any questions. Okay. So I see, for example, do we have any other graphene-based solutions aside of solid on master batch? Yes, for example, we can also do different kind of liquid dispersions. We can also make wet powders, for example. We are extremely flexible in terms of adapting the graphene-based solutions to your particular processes and materials and requirements. And whenever you have particular projects, let us know. We will see if it's best to propose a standard product or to prepare something particularly for you, of course. I see another question in the market. I see graphenes between $4 to up to $4,000 per kilo. Why these differences? Is it worth it to work with products that cost 4,000 euro per kilo? Well, it will depend. As I said at the beginning, right now in terms of status quo of production of graphene, there are different grades or different production methods. Some of them are more oriented towards lowering costs and increasing capacity. Logically, this is most interesting for industrial purposes, where in some cases you don't need the extremely pristine and perfect characteristics of the best version of graphene, because logically you have to find the right compromise between performance and price. But particularly for research grades, which are the graphene grades, which are on the higher price side, logically here they are researching not only the characteristics, but also the potential of graphene in new applications. And in some cases, there may be applications that maybe are not even developed industrially. And here, for example, it's very interesting to see what graphene is capable in terms of new materials at the end of the day. All right. 10 to the power of 6 at which use level? Well, this will depend. Well, first of all, are we talking about antistatic, a colorable antistatic, or a graphene grade? And it will depend on your material and the additive that we propose. But feel free to contact me directly to tell me a little bit more about in which specific material you want to achieve this, and I will be happy to help you with it. Is Avanzare in master batch form or powder, liquid? If master batch, what is the carrier? Yes, of course, the Avanzare GR8 is a graphene product in powder format. It's the basic form, but logically we can prepare different master batches, for example, in EVA, in polyamide 6. You have to tell us also where you would like to integrate it in case it would make sense, for example, to make it even in a similar or even in the exact same carrier, also for you to have the least effect in terms of mechanical properties in your material at the end. Yeah. Very well. Yes. Anti-fog, for example. Yes, someone is asking about anti-fog, if it is suitable for PET. I would need to double check this, but in principle, I think it would not be a problem. And it is, if I'm correct, in powder form. Logically, whoever wrote this, feel free, please, to contact me directly, and I will be happy to have a chat with you about it and which particular grade we would propose. And yes, I believe these are all the questions so far. We will share this presentation with all the attendees, and if you don't get it, feel free to contact me directly so that I can send it to you. Also, I want to highlight that this webinar will be posted, and all the previous webinars are posted in our YouTube channel. So please feel free to subscribe to keep updated. And yes, another question I see. Are your permanent antistatic solutions all suitable with the European food contact? Not all of them. As I said before, we have specific grades that are suitable for food contact. Whoever wrote this, please contact me directly, and I will be happy to propose the most suitable grade depending on the polymer, where you want to integrate it, and of course what you want to achieve. As I said before, it's very important to look at the production process, at the processing temperature, and the resistivity that you want to achieve, of course. Very well, I believe. All right. Yes, some of the other questions I see that were already answered by Javier on the chat. So once again, I would like to thank you all for joining this webinar. I look forward to hearing from you and to establish a relationship. Maybe not, maybe if you don't have them particularly now for particular project, but I think it's always good that we are in touch, that we exchange ideas, brainstorm, in case whenever the time comes, we can help you in the best and most efficient way. Thanks a lot, and I wish you a great day.